Let's do one more example question involving speed of light. This is not a Michelson problem, easier than a Michelson problem. It just involves general speed of light. It's a question that, to be honest, you could have done in Physics 20 if you knew what the speed of light was, 3 times 10 to the 8 meters per second. The question says the distance from Calgary to Regina is 800 kilometers. How long does it take for light to travel from Calgary to Regina? If the wavelength is 600 nanometers, what's the frequency? I want to add one part to this. I want to say, what is the period of the wave? So we start writing down some givens here. We say the distance traveled by the light is 800 kilometers, which, remember to convert that to meters, it's 800,000 meters. We have a wavelength here of 600 nanometers. You want to know how to write that? 600 nanometers. Just replace the n with 10 to the minus 9. And if you don't know that number, 10 to the minus 9, just check your data sheet. It's there. We're looking for how long it takes, t. We're looking for the frequency. And we're looking for the period, capital T. Is there anything else that we have if we read between the lines here? Yep. Good. The speed of light, which sometimes we call v, sometimes we call, what's the other symbol for it? V or c. I'm going to call it c here. 3.00 times 10 to the 8 meters per second. Okay, let's do the first one here. Solve for the time. We're going to say v is equal to d over t, or t is equal to d over v. D is 800,000 meters. Divided by v, which we said is c, v, c, whatever you want to call it, 3 times 10 to the 8 meters per second. I solve for time there, works out to be 2.67 times 10 to the negative 3 seconds. Yep. Could you, so for the first part of it, you mean? Okay, to find the frequency, absolutely. Yeah, and we are going to do that in a second here, okay? We focused right now on finding what the time was. You could have found frequency first instead of the time, absolutely. Yeah. Yep, Parker? That's correct. 600 nanometers, we just replaced the n with 10 to the minus 9. So 600 times 10 to the minus 9. That's not truly scientific notation, because scientific notation is number, decimal, number, right? Scientific notation would be 6.00 times 10 to the minus 7. I would suggest not going there. Just write the 600 down as is, and then replace the n with the exponent that's on your data sheet, 10 to the minus 9. Then you don't have to worry about moving the decimal place and messing up on that. All right, that's the time that it takes. Remember Galileo's experiment? He tried to measure by hand the time that it took light to travel 2 kilometers. It takes 0.00267 seconds to travel 800 kilometers. The time that it takes to travel 2 kilometers is ridiculously small. So his reaction time, as we said a number of times, way, way, way too big. That's why his experiment didn't work. It wouldn't have even worked if he had one guy in Calgary and one guy in Regina uncovering lanterns. For 2 reasons. 1, because the time is still so ridiculously small, and 2, because I don't think there's any hills in Regina. And he needs those 2 hills, right? All right. I want to find the frequency. Matteo, you told me a second ago how to find the frequency. What was it? Sure. V is equal to F times lambda, or F is equal to V over lambda. V is, once again, C in this context, 3 times 10 to the 8 meters per second. And lambda is 600 times 10 to the minus 9 meters. And that gives me 5.00 times 10 to the 14 hertz. We're not required to identify what type of EMR that is, but if you were, Anna, what kind would it be? 5 times 10 to the 14. Help her out a little bit? Tim? Yeah, do visible light. Visible light, remember, is 4 to 7.5 times 10 to the 14. And finally, we want to find the period. Any ideas? Nope. Nope. Janae? Yeah. T is equal to 1 over F. 1 over 5 times 10 to the positive 14, which I believe, double check this for me, is 2 times 10 to the negative 15 seconds. You know, it's not crazy. This is really physics 20. It really is. Okay. The Michelson experiment was harder than typical physics 20, but it's always the same. So you can kind of make it a physics 20 non-thinking question. This is just pretty much straight from physics 20, except that you're given the speed in all the questions, 3 times 10 to the 8 meters per second, even if it's not explicitly stated in the question. So have a look over the next 10 minutes at worksheet number 15, but only question numbers 1 to 4, please.